In this video, we'll look at how to differentiate powers of x. We'll need to use the standard rule for differentiating a power of x, which is, if y equals x to the power n, then dy by dx equals nx to the power n minus 1. So we multiply the x by the original power, and then we drop the power by 1. Let's see an example of this. Say we have the function y equals x to the power 8. Well, using this rule, dy by dx would be 8x to the power 8 minus 1, which is 8x to the 7. Let's look at a few special cases also. What about when y equals x? Well, this is the same as x to the power 1. Then, using the rule, we get dy by dx equals 1 times x, which is just x to the power 1 minus 1, which is x to the 0. This is just 1. What about y equals 1? Well, this is the same as x to the 0. So we get dy by dx equals 0x to the power 0 minus 1, which is minus 1. This is of course just 0. Using this rule, we could easily differentiate any function like these ones. But what happens when our function is the sum of several powers of x? Well, differentiation is linear, which means we can differentiate each term in the sum separately and add them up. It also means we can take constants outside the differentiation. We can put this formally by saying that d by dx of a1 x to the n1 plus a2 x to the n2 plus a3 x to the n3 and so on is equal to a1 times d by dx of x to the n1 plus a2 times d by dx of x to the n2 plus a3 times d by dx of x to the n3 and so on. Let's try this on a couple of examples. Let's take y equals 6x to the 4 minus 3x squared plus 7x minus 8. Let's start by writing every term as a power of x. So the first two terms are fine. The third term is equal to 7 times x to the 1, and we can think of the fourth term as minus 8 times x to the 0. So dy by dx equals d by dx of 6x to the 4 minus 3x squared plus 7x to the 1 minus 8x to the 0. Using our rule, this equals 6 times d by dx of x to the 4 minus 3 times d by dx of x squared plus 7 times d by dx of x to the 1 minus 8 times d by dx of x to the 0. Now we do the differentiation using the rule at the top, so we get 6 times 4x cubed minus 3 times 2x to the 1. This is the first two terms. For the second two, we can use the earlier examples. We get 7 times 1 minus 8 times 0. This equals 24x cubed minus 6x plus 7. The final term disappears since we multiplied it by 0, so this is our final answer. Note that we wrote a few superfluous things here, just to make the method clear. For instance, we wrote the constant term 8 as 8x to the 0, then when we multiplied by the 0, the term disappeared. It will always be the case that the constant term disappears. Similarly, we wrote the x term 7x as 7x to the 1, but then the x part disappeared and we ended up with just the constant 7. Again, this will always be the case. So, bearing these things in mind, let's do a second example. Let's take y equals 7x to the 5 plus 6 over x squared minus 2x minus 4. First, let's rewrite this slightly. So this equals 7x to the 5 plus 6 times x to the minus 2 minus 2x minus 4. Now we can differentiate using the rule, so dy by dx equals, well, let's try differentiating each term straight away. So we get 7 times 5x to the 4 plus 6 times minus 2x to the minus 3. Then we have minus 2, the x just disappears. The constant term minus 4 also disappears. This equals 35x to the 4 minus 12x to the minus 3 minus 2.